Multiplying matrices. Find the product if possible. In this question, I'm going to show you different cases of matrices when we multiply them. Sometimes it's possible and sometimes it's not possible. I'll show you both cases. So in the first case, we have a matrix 5, 2, -3, 0 multiplied by -2, 1, 1, -1. So now, to check if the product exists, we have to check the dimensions of the matrix. If you look at the first one, its dimensions are, we count the number of rows first, and then we count the number of columns. Then we say it's 2 by 2. So we say 2 by 2. And the other one, it's also it has 2 rows and 2 columns. So we say it's also 2 by 2. So when we write the numbers, we write the rows first and the columns second. And after that, we look at the middle numbers. They call the inner. So we say 2 and 2. If they are equal, then the product exists, and then we can multiply the matrices. And to apply the product, the result matrix would be the outer, which is 2 by 2 matrix. So the final product is going to be 2 by 2 matrix. So we write and we make space just because we have product, and then the product, it will take a small process. Let me show you the process of the multiplication. The process is we look at the first row, and then the elements inside we distributed among the elements in the first row in the second one, in the second matrix. So we take the row and the first column, and we do the operation. We multiply 5 by -2, and we do 2 times 1, and we add the product. So 5 times -2, which is -10, plus 2 times 1, which is 2. So this would be the first element in the resultant matrix. We do the same process with the second column. So we multiply 5 by 1, 2 by -1, and then we add them. So we say 5 times 1 is 5, plus, and 2 times -1, which is -2, and then we add them, and we get the result. We do the same process as we did for the first row with the 2 columns in the second matrix. We do it with the second row in the first matrix. So we do -3 times -2 and 0 times 1. So we say -3 times -2 is +6, plus 0 times 1, which is 0. And for the second one, we say -3 times 1, which is -3, and plus 0 times -1, which is 0. And this would be the final matrix. So let's find the result. Take this little bit up, and then we write the result of the final matrix. So we do the calculation. -10 plus 2 is -8. 5 plus -2 is 3. And 6 plus 0 is 6. -3 and 0, which is -3. So this would be the product of the first two matrices. If we apply the same process we did for the second question here, so we do the same process. So we say 2 times -3 minus 4 times 1. I'm going to do this faster than that because already you followed the first question and then you know the process. So we take the first row multiplied by the first column in the second one, first row by the second column, first row with the third column, and then we put the numbers here. So 2 times -3 is -6, -4 times 1 is -4, so -6 minus 4 is -10. The second one, 2 times 2, 4, -4 times -1 is 4, so you get 4 plus 4 is 8. 2 times 0 is 0, -4 times -2 is 8, so we get 0 plus 8 is 8. Here, 1 times -3, 3 times 1 is 3, so -3 plus 3 is equal to 0. And we say 1 times 2 is 2, 3 times -1 is -3, so 2 minus 3 is -1. 1 times 0 is 0, 3 times -2 is -6, so 0 minus 6 is -6. We can see the third example, like here. Let me just make a space here, and then do that in that area. Okay, so if we follow the same procedure as we mentioned before, so we say the first row with the column, and since we don't have other than one column, so we have only to multiply those by this, and we get only one element in the second one. So we open a matrix, and then we multiply 2 by 4 is 8, and minus 4 times 3 minus 12. So we have only one number here, and we multiply then with the second row. 1 times 4 is 4, plus 3 times 3 is 9, plus 9 you get, final matrix is 8 minus 12 is minus 4, and 4 plus 9, which is 13. So we get only the resultant matrix is 2 rows and 1 column. And let me show you why do we get this. If you look at this matrix, it's 2 by 2, 2 rows, 2 columns, so it's 2 by 2. And while the second one is 2 rows and 1 column, so it's 2 by 1. This is 2 by 1. So if we look at the inside, we can multiply. So, and you have, as you have seen in the product, we could multiply, but the resultant matrix is 2 by 1. And here we have 1, 2, and we have 1 column, so which is correct. Let me show you another example where the product doesn't exist. So with the same questions that I mentioned previous, so I'm going to switch the matrices. I'm going to switch the product. I'm going to put this first and this second, and show you if we want to multiply them, how does it happen. So if we look at the first matrix, it's 2 by 1. So this is 2 by 1. And if we look at this matrix, it's 2 by 2. So this is 2 by 2. Now look at the inner. The inner is 1 and 2, so they are not equal. So in this case, we cannot multiply these two matrices. And if we want to do that, let's say, if you want to follow this, the procedure we followed. If we look at the first row, so we have in the first row one element. So this multiplied by this. Then what do we have to multiply by 1 in the first column? So in this case, we cannot multiply or perform the product. So if we look at the second one, here, let me switch also. If we switch here and we put this second. So if we look at the product, let's look at the dimension first. 1, 2, 1, 2, 3. So it's 2 by 3. Here we have 1, 2, 1, 2. So it's 2 by 2. So if we look at the inner are 3 and 2. So they are not equal. So in this case, we say the product is impossible. Let's try also, as we mentioned, to multiply the first row by the first column. So if we look at that, minus 3 times 2, 2 times 2, and 0 times nothing here. So there's nothing to multiply by 0, so there's no compatibility between these two matrices to perform the product. So we say product does not exist. Thank you.